Precalc Chapter 11, Section 3. So we're going to use the tangent line to approximate the slope. We talked a little bit about that yesterday, and use the limit definition of slope, and then find derivatives of a function. Use derivatives to find slope. Approximate the tangent line using a graph, or we can use the secant line. So the secant line is the change in y over change in x. Find the slope of the secant line. Can be found, so m of SEC is a secant slope. So the slope of that is found by doing the f of x plus h minus f of x. So that's subtracting our y values. So that's taking this y by here minus the other y. So this right here is going to be the change in y. So we're subtracting the two y values. Divided by the h value, where h is the change in x right here, change in x. So change in y divided by change in x, which is our slope. If h equals 0, so we're letting the h value, which is the change in x, be 0, we have the tangent line, but the denominator may not equal 0. So we can't just say let h equal 0 because it can't. But we can write it as the limit. So the slope of m of f at point x f of x is equal to the slope of its tangent line at x f of x, given by this. So the limit of h as h approaches 0 of the slope of the secant line, which is equal to this, which is the limit as h approaches 0 of the difference of quotient, provided the limit exists. And so this is how you find the slope of the tangent line, is to find the slope of that single point given this limit exists. So find the slope of f of x equals x squared minus 4x at this point. So we're trying to find the slope. We want to know what m is at x equals 3 for the function f of x equals x squared minus 4x. That's another way of writing that. What is our slope at x equals 3 for this function? It's the slope of the tangent line. So to do that, we have to do the limit as h approaches 0 of the difference of quotient. So if I use the substitution, it's going to be x plus h squared, so that's like x squared, minus 4 times x, which is x plus h, minus f of x, which is the x squared minus 4x, all over h. So we can do some simplifying here. So let's FOIL that first one. So we get x squared plus 2xh plus h squared minus 4x minus 4h minus x squared plus 4x all over h. Notice how I distribute this negative as well. Let's simplify our numerator. So we have an x squared here and a minus x squared, that's 0. We have a minus 4x and a plus 4x, which is 0. So now everything left over just has h's. So let's reduce that. So this h reduces with one of these h's, one of those, and that h. So we're given the limit as h approaches 0, what's left over, which is 2x plus h minus 4. And then now that we got rid of that denominator, now we can go through and use direct substitution to find the limit. So plug 0 in for h, and you get 2x minus 4 is going to be the equation for the slope of x squared minus 4x. Now we want to find slope at x equals 3. So now let's plug 3 in for x. So if x, when we plug it in, then we know our slope is going to equal 2 times 3 minus 4, which is going to be 2. So then we found the slope. The slope is going to be 2 at x equals 3. So that's what we're going to end up having. Sometimes we can just find the formula. That's kind of just using the difference of quotient. The formula for slope, so that's going to be the limit as h approaches 0 of 4 of 4 minus x squared, which again, substitute x plus h in that, minus f of x, which is just our function, all over h. So we can simplify. We have to first FOIL that. So x squared plus 2xh plus h squared minus 4 plus x squared all over h. Now I can distribute this negative in front, so be careful with this. You actually need to do the foiling and then distribute this negative. So we're finding a limit as h approaches 0 of 4 minus x squared minus 2xh minus h squared minus 4 plus x squared all over h. Simplify, so we have our 4 minus 4 and negative x squared plus x squared, so we end up with the limit as h approaches 0. I'll also reduce my h's here, so we have negative 2x minus h. Direct substitution, so we have negative 2x is the equation. That's the equation for the slope at any x value. So now we can find the slope at 0, 4, and let's find the slope at negative 1, 3. So there's two different questions here. If x equals 0, then the slope m, just plug 0 in there, you get 0. At x equals negative 1, then the slope is going to be 2. And so we can find the different slopes values at different x values. If we look at the original function here, 4 minus x squared, that equation, that graph, is going to have up here at 4 is our y-intercept. It's just going to be a parabola opening down. So at x equals 0, the tangent line is this tangent line, which is a horizontal line. And once the slope of a horizontal line is 0. I'll talk more about this in the near future. And then at x equals negative 1, we have a slope of 2, so that'd be like a tangent line over here. So the equation negative 2x is called the derivative of f at x. So negative 2x is an equation that represents the slope of f at some value x. So the derivative is the definition here. The definition of the derivative is doing the limit as h approaches 0 of the difference in quotient. And that's what we have here, the derivative, which the notation is going to be f prime x. That's the derivative, is the limit as h approaches 0 of the difference in quotient, the slope. So we can find the derivative of this equation, which looks quite complicated. Give that a shot. So it's going to be x plus h to the 4th minus 2 times x plus h squared all over h. So we have to simplify this. Now, this is x plus h to the 4th. So I have to multiply 4 of these binomials together. And I don't want to do that the long way. So I'm going to use our knowledge from chapter 8, where I can look at Pascal's triangle. So this is 0, 1, 2, 3, row 4 is right here. These are my coefficients. When I'm expanding x plus h to the 4th. So it's going to be 1 x to the 4th, h to the 0, plus 4x cubed h to the 1st, plus 3, or actually, plus 6 x squared h squared plus 4 x h cubed plus 1 h to the 4th. So that's just multiplying together that first 4 power. Did not notice I did forget part of my derivative. I did not subtract the function f of x. So I caught that. So there would be the actual derivative. This is still the first part. And we're still subtracting 2 times x plus h squared. Now that I can just FOIL quite quickly. X squared plus 2xh plus h squared. Then I have to distribute my negative here to the x to the fourth power, and I get plus 2x squared all over h. So we can write down our simplified form here. We can also reduce this h goes in, can reduce this h can reduce with the h's in the numerator here. So that's 2, that's 3, it's going to be 1, that's going to be gone, that's going to be gone, and that's going to be 1. So we can write what's left over here, and we get 4x cubed plus 6x squared h plus 4x h squared plus h cubed minus 4x minus 2h. Now I can find the limit as h approaches 0, and that's used to using this direct substitution. So I can plug 0 in for these h values, and when I do that, each of those terms are multiplied by 0, so those all become 0, 0, 0, and 0. So I'm left with 4x cubed minus 4x. This is the derivative of our function f, so we could call that f prime. So f prime of x is equal to 4x cubed minus 4x. Now, the deeper question is, do you see a relationship between there? How you can get there quickly using a shortcut? We could use the derivative to determine any points on the graph of f at which the tangent line is horizontal. So, if the tangent line, which the slope of the tangent line, the slope of tangent line is how is found by using this derivative. That's what the value would be. And so we can use the derivative here to find any points where the tangent line is horizontal. So a horizontal line has a slope, horizontal has a slope of 0. So I'm really asking, when is the derivative equal to 0? So I can say 4x cubed minus 4x and set it equal to 0 and solve. To do that, I can factor out of x. I'm left with 4x squared minus 4 equals 0. Set each factor equal to 0, so we have x equals 0. And this one here can set it equal to 0, so I get x squared, add 4, divide by 4, so it equals 1. So that x equals plus or minus 1. So we have 3 different spots for this cubic function where the graph has a tangent line that's horizontal. If we look at this graph, so this equation right here, the derivative, is talking about the original function f of x. So if I look at the graph of f of x, it's going to have a W shape because it's x to the 4th positive a value. So I know that the tangent line is going to have these horizontal tangent lines at these 3 spots. So those 3 spots are going to occur at x values of plus or minus 1 and 0. So like negative 1, 0, and 1 would be the x values where those horizontal lines occur. And this is important because look at those points. Those points are all of our relative extreme. These are our max and mins. So where the tangent line is horizontal, or when the derivative is 0, is how we find our max or mins. The derivative helps us find our max or mins for these problems. So instead of having to use some of our previous knowledge with our quadratics to help us find the max and mins, we can use a much quicker way with our derivatives to find max and min. So some other notation for the derivative, f prime of x is dy over dx, y prime, d over dx of f of x, and then dx of y in brackets. These are different notations that all mean derivative. I know in college I used a lot of these right here. These are the 3 you tend to use. I like the f prime of x, but I see them all within the calculus. So we're going to call it good for 11.3, and we'll see you tomorrow.